Hi friends, welcome to our channel. In this video, let's discuss few numerical problems that is related to the topics that we discussed so far, that is distance, speed, velocity and acceleration. So let's begin. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, 3 into 10 to the power 8 meters per second. So in this question, they are talking about a spaceship and the signal which is traveling from the spaceship. So basically, there is a spaceship here. Let's denote it with SS, and let the ground station be here, GS. So there is a signal which is traveling from the spaceship to the ground station. Okay, and this signal, it is reaching the ground station in 5 minutes. That means the time taken by the signal to reach the ground station from the space station is 5 minutes. What was the distance of the spaceship from the ground station? So they're asking about this distance between the spaceship and the ground station. So they're asking about distance. We denote a distance with the letter S. And it is given that the signal travels at the speed of light, 3 into 10 to the power 8 meters per second. So the speed of the signal is given as 3 into 10 to the power 8 meters per second. So in order to calculate distance from speed and time, we can use this formula. Speed V is equal to distance by time. Distance is denoted by S and time is denoted by T. Alright, so here in this question they are asking us to find distance. So let's rewrite this equation as S is equal to V into T. And we have V and we have T. So we can directly use this formula. Now before substituting the values into this formula, we must check that whether the units are consistent or not. Here time is given in minutes, whereas speed is given in meters per second. So we need to convert this minutes to seconds before substituting into the formula. This is a very important step that you guys need to keep in mind. So what is 5 minutes? When we convert 5 minutes into seconds, what happens? Here we know that 1 minute is equal to 60 seconds. We are using this formula to convert minutes to seconds. So 5 minutes will be 5 into 60, that is 300 seconds. Now let's substitute those values in this formula. V is 3 into 10 to the power 8 and T is 300 seconds. That is 900 into 10 to the power 8 meters, right? We are calculating distance, right? So distance is in meters. Now, either you can keep your answer in this form or else we know this conversion. 1 kilometer is equal to 1000 meters, right? So let's rewrite this. Can I write this in this form? What did I do? I just took out 1 0 from this 8 and added here. So now this becomes 9 kilometers, right? This will be the final answer for the question. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 kilometers per hour in 10 minutes. Find its acceleration. So the train here is starting from a railway station. That means the train was initially at rest. So u is equal to 0. 0 kilometers per hour. Since the train is starting from railway station, we can say that the train was initially at rest. So initial velocity or initial speed is 0. Now after that, the train is moving with uniform acceleration and attains a speed of 40 kilometers per hour. So here the speed of the train is given to be 40 kilometers per hour. So we can take this speed, that is the speed 40 kilometers per hour, as the final speed of the train, is equal to v is equal to 40 kilometers per hour. And then the time is given as 10 minutes. T is equal to 10 minutes. The question is asking to find the acceleration of the train, A. Okay. Now, to find acceleration, we have this formula. A is equal to final velocity or final speed minus initial speed by time. Before substituting the values into the formula, let's check the units of the quantities. Here, velocity or the final velocity is given as 40 kilometers per hour and the time is given as 10 minutes. So for our convenience, let's convert all of these units to SI units. That is, let's convert the speed to meters per second and time to seconds. Okay, so the conversion of speed from kilometers per hour to meters per second is given this way: 40 into 1000 by 3600 meters per second. If we simplify this, we'll get it as 100 by 9 meters per second. Okay, that is, we are converting kilometers per hour to meters per second. We know that 1 kilometers is equal to 1000 meters, right? That's how the 1000 came in the numerator. And we know that we know how to convert hour to seconds, right? That is, 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So what will be 60 minutes? It will be 60 into 60 seconds. That's how 3600 came in the denominator. So basically, to convert from kilometers per hour to meters per second, you just need to multiply with 1000 by 3600. So this is the speed in meters per second. And now let's convert time in minutes to seconds. So this will be 10 into 60 seconds. That is 600 seconds. Here I have used the same formula. 1 minute is equal to 60 seconds. So 10 minutes will be 10 into 60. That's 600 seconds. So let's use this formula to find acceleration. Here, acceleration will be, what is final velocity? That is 100 by 9 minus initial velocity is 0 by time is 600. So if I simplify this, I get 100 by 9 into 600. The final answer is 1 by 54 meters per second square. The tip of a second's hand of a clock takes 60 seconds to move once on the circular dial of the clock. If the radius of the clock be 10.5 centimeters, calculate the speed of the tip of the second's hand of the clock. So in this question, it is talking about the seconds hand of a clock. That is, we know that for any clock, there is an hour hand and then there is a seconds hand. And this seconds hand, it takes one complete round of the circle or of the clock, and then that complete round will be 1 minute, right? That is 60 seconds. That is what is given in the first line. The tip of the seconds hand of a clock takes 60 seconds to move once on the circular dial of the clock. So the time taken by the seconds hand to move once around the circular dial is 60 seconds. If the radius of the clock be 10.5 centimeter, calculate the speed of the tip of the seconds hand of the clock. They are asking us to find the speed of this seconds hand. Now, it is given that time is equal to 60 seconds and radius of the clock is 10.5 centimeters. The question is to calculate speed, right? So let's write the formula for speed. Speed is equal to distance by time. We have the time. Now what is the distance? This seconds hand, it covers one complete circle in 60 seconds. One complete circle means it is the circumference of the circle, right? That is, if the seconds hand is starting from this point, after 60 seconds it will go once around the clock and then reach the same point. In that case, we can take distance covered by the seconds hand as circumference of the circle. Distance covered is equal to circumference of the clock. What is circumference of the clock? Circumference of any circle is 2 pi r, and we have radius of the clock, that is 2 into 3.14 into 10.5 centimeters. 3.14 is the value for pi. This expression, if you calculate, we will get the answer as 66 centimeters. Now we can calculate speed directly. That is, speed is equal to 66 centimeters by 60 seconds. That is 1.1 centimeters per second. This is the speed of the seconds hand of the clock. Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Here, Usha is swimming in a pool that is 90 meters long. So there is a swimming pool which is 90 meters long. So let's consider the pool to be a rectangle, and we have given one side of the pool is 90 meters. Okay, so Usha, she is starting from one end and she is swimming from this end to the other and back along the same straight path. That is, if Usha started from this point, she swimmed till this end and then swimmed back along the same straight path. So the total distance covered by Usha will be 180 meters. That is 90 plus 90. 90 in this direction and then 90 here. So 90 plus 90 is 180 meters. That's what it is given here. She covers 180 meters in 1 minute, and this 180 meters is covered in 1 minute. we are asked to find the average speed and average velocity of Usha. That is average speed and average velocity of Usha. Alright. Now before we begin, let's make sure that all the units are same. Here distance is given in minutes, time is given in minutes. So we need to convert minute to seconds. So 1 minute will be 60 seconds. And we will be finding speed and velocity in meters per second. Alright, so let's begin. We know that the formula for average speed is total distance covered by total time taken to cover the particular distance, right? Here the total distance is 180 meters. 180 meters, and the time taken to cover this 180 meters is 60 seconds. So here the speed will be 3 meters per second is the average speed of Usha. Now next we are asked to find the average velocity. Average velocity is equal to total displacement by total time. Now, in this case, what is displacement? Okay, before that, what is displacement in the first place? Displacement is the shortest distance between the final and initial points. Here, Usha was starting from this point. So, this will be her initial point. And then she is swimming to this point and then back to this point again. So, this becomes her final point also. So, in this scenario, the final and initial point was coinciding. Thus, the displacement will be 0. So, displacement is 0 by time is 60 seconds. So, average velocity is anyways 0 meters per second. I hope you guys understood why average velocity is 0, because in this case the displacement is 0. Why? Because here initial and final points were coinciding, so that shortest distance between initial and final point is 0. So that is what is displacement, right? So displacement is 0. Thus average velocity comes to be 0.